Hello world, it's Sumit. So in today's session, we're going to discuss about evaluation metric, which we often call as a loss function, and this is only for the types of algorithm which do fall in the classification and clustering model. So I recommend you to watch one video in this playlist, which could be the first video where you will need to know like what kind of algorithm do fall under which category, for example, which fall under this classification and clustering model. So on moving ahead, I'm going to give you a brief outline of what we're going to cover up in today's topic. First would be evaluation metric for classification and clustering model, where we're going to see that like what is evaluation metric and what are the different types of it. Then we're going to move ahead in knowing like what is confusion metrics. Then we're going to see the difference between normalized and non-normalized confusion metrics, and at last we're going to jump into the code snippet to know like how we can call different APIs to use this evaluation metrics. Okay, so the first thing come is like what is evaluation metric and what it has been used for. So evaluation metric is just a technique that has been used to judge the performance of your model. So basically it has been often been called as a loss function, and the result from evaluating the model using any metric is used to judge the benchmarking accuracy of your model prediction over any trained data set. So, for example, if you go and take up any exams so against your skill set, at last the result will going to get published stating like how well you had performed in that particular exam. So that is just used to validate you like how well you are good at that particular data set. So in a similar way, we also used to train our model using training data set, and we used to validate our model using testing data set, like how well it is in performing in the prediction, like how accurate our prediction is. So this is what evaluation metric is, and that has been used for. So there are different types of model evaluation metric. First is confusion metric, which can be again be classified into normalized and non-normalized confusion metric. Again is classification report, and third is accuracy score. So we're going to take up this confusion metric and discuss in detail about it. Okay. So the next thing come is like what is confusion metric. So confusion metric is just a simple metric which evaluates the quality of the output of any classifier on any given data set. Let's say I got 2 by 2 matrix if I want to plot it. So if you're in the column wise, if you're going to plot all the predicted class, and in the row if you're going to take up as an actual class, so there are some different terminologies like true positive, false positive, and true negative, which we're going to talk about in later part of the video. So if you're going to plot this 2 by 2 matrix, so in that like what the diagonal elements which you are seeing here, like for example this diagonal element represents only the number where the predicted label is been equal to the actual class. Like for example, like for like what our prediction has been made through the model is been equal to this actual class, whereas this off diagonal elements which we are seeing here, so these represent the number which had got mislabeled by the classifier, which means the higher the value of this mislabel thing, the less accurate your model is, and the higher the value of this diagonal element across the metric, the greater the accuracy of your model, indicating that many correct prediction. So there are some different terminologies like which you can use, like all this which we're going to talk about later, and there are some different formulas which you can use to calculate this confusion metric, as like sensitivity, specificity, accuracy, negative predicted value, and precision. So on moving ahead, next is knowing about different terminologies of this confusion metric. So if you're going to plot this 2 by 2 matrix, and if you're going to take the predicted class across our column and the actual class across our rows, in that case where the actual class is the patient like who can get pregnant, whereas the predicted class is something like what doctor will going to predict. So in that case, the first would be like what is true positive. So true positive comes like when the predicted class is also positive, where the actual class is also positive. For this example, if you're going to take up this positive scenario, and this lady is pregnant, whereas the doctor is also confirming her by doing any diagnosis or something, yes, you are pregnant. Then in that case, it will going to fit the scenario of this true positive. Whereas for this true negative, where the predicted class is negative and actual class is also negative. For example, for this scenario, if the predicted class is negative, where the predicted class was the doctor, what he will going to predict, and the actual class was our client or the patient who will going to get pregnant. So we can clearly see here this our actual class cannot get pregnant. So our actual class is negative and predicted class is also negative, where the doctor is confirming him saying like no, you are not pregnant. This also fits the scenario of this true negative, which we often call as true negative. Next is knowing about the false positive, which it has been often called as a type 1 error, where the predicted class is positive and actual class is negative. So for this scenario, the predicted class, as you can see, predicted class is a doctor, what he will going to pregnant, like what he will going to predict, saying like yes, you are pregnant. Whereas the by clearly seeing the scenario saying like this particular man cannot get pregnant, like he cannot be naturally, so in that case it could be come under the sense of this false positive, which we often call as a type 1 error. And the last would be knowing about like false negative, which we often call as a type 2 error, where the predicted class is negative and actual class is positive. For example, for this scenario, the negative the predicted class is negative, saying in the sense the predicted class, the like what doctor is going to predict. So doctor is predicting her no, you are not pregnant, where the actual class is saying as positive. So the positive is like by seeing her, everyone knows like yes, she is pregnant, but the doctor is confirming her no, you are not pregnant. So this type of error will going to fall under this type 2 error. So this were the different terminologies related with the confusion metric. So hope you got to know about this true positive, true negative, false positive and false negative. So after knowing about the different types of terminologies of So after knowing about the terminologies of the confusion metric, we're going to talk about the different types of confusion metric, that is normalized and non-normalized confusion metric. So if you can see clearly, this is kind of an 3x3 confusion metric, this metric, and this is normalized confusion metric, whereas this is without normalization. Why without normalization? If you can see clearly, this value is been ranging from 0 to 12. These are the kind of raw value, whereas for this normalized confusion metric, value always do lies between 0 to 1. And from the code snippet, to make you understand in a better way, this is just a sample code snippet. So this is a 3x3 confusion metric, whereas the same, it depicts the same thing. So in normalized confusion metric, if you can see, one more point is like if you can see the sum of all the columns of that particular row, for this particular row Setosa, if I am taking the sum of all the columns, you may notice that it may end up adding up to 1, saying about if you do the summation of all the column for that particular row, it would be always be equals to 1. So similarly for this row as well, it has been equal to 0 plus 0.62 plus 0.38, it would be 1, and same for this as well. So in normalized confusion matrix, the sum of the row of all the column for that particular row, it's been always should be equals to 1. And if you can see closely, like this is all the diagonal elements, and which had been predicted correctly by the model, where these are kind of off diagonal elements. So this one, this one, this one, and this one, this one, this one, which you can say is kind of an elements or the number which had been kind of mislabeled by the classifier. So the higher number of all this value, the less accurate your model is. So for this particular model which had given the prediction, you can see there are some values like 0.38. So by looking at this, we can clearly say like model is good, it's been performing good, but there are some few points or the number which had been called mislabeled by the classifier. So that was the difference between normalized and non-normalized. Oh, I had made myself clear on this. So after knowing about the types of confusion metric, at last we're going to jump into the code snippet. Well, we're going to learn about using sklearn library, how we can call different APIs to know about the different types of evaluation metric, how we can call them in the code and how we can use it. So the detailed video of this I would be uploading while doing the practical session, but for as of now in this theory session, these are the way which you can call. For example, for the classification report, in the first we had talked about, there are three different types classification report, accuracy score and confusion metric. So for the classification report, we need to import this library called classification report from sklearn.matrices, and we can simply pass on our white test data and the predicted value, what had got predicted. This is kind of unseen data which we had talked before, and this is kind of predicted value. So if we're going to pass on it, it's going to give us a different value saying about the precision, recall, F1 score and support. Similarly, for this confusion metric as well, we can import this confusion metric and we can pass our test data and the predicted data to know the accuracy of it. So here you can clearly see this is a 2 by 2 metric, whereas like this diagonal element represent the number which had got rightly predicted by the model, whereas this off diagonal element as a 13 and 32 represent this is kind of like which had got mislabeled by the classifier. And for the accuracy score, the same way we can pass on our white test data and predicted value to know the exact score, like how well accurate our model is. So this was from the code snippet. To summarize up all this thing, what we had learned up till now, to give a heads up to what would the major takeaway was, like the knowing about like what is evaluation metric and what are the different types of it, for what it has been used. Then next we got to know about confusion metric, like what it is and the different terminologies associated with it. Then we got to know about the types of confusion metric using the code snippet as well in detail. And at last we jump into the code snippet to know like how the different types of our matrices can be called in the code snippet to know the accuracy of your model. So if you really liked my video, please do like, share and subscribe Cupula on my YouTube channel, and hit the bell notification icon for any new video update. And you can also give your feedback through comments, which could help me to improve on my video to come up with a more videos like this. Thank you all.